Glad you could join us today on EarthFile. Welcome to the program. I'm Ayola Kasim. Cowpea, or black-eyed pea, commonly called beans, is high in protein and several vitamins and minerals. Nigeria is the largest grower and consumer of the crop, but current realities have shown that the country is experiencing demand deficit of over 500,000 tons, while national productivity average has stagnated at 350 kilograms per hectare. Recently, the government released BT cowpea, which is said to be resistant to the pod borer insect. It is a genetically modified seed, and that is where some say the problem is. For the challenge of food security and climate change, what is the place of GMOs in our food chain? That's our focus today on the program. Just stay with us. Sulaiman Aliyu is a cowpea farmer in Zaria, a major city in Kaduna State in northern Nigeria. He has been farming for more than 25 years, and for him the problem has remained the same over the years: poor yield, drudgery, and low profit.
It's about 25 to 26 years since we have been farming. For now, we only make do with the local variety, which isn't giving us the volume of yield we expect. One goes into the beans farming every season, but have very little to show for it at the moment.
Cowpea grain is inexpensive and nutritious. It serves as a cheap form of protein for both rural and urban consumers. In Nigeria, cowpeas are consumed directly as a nutritious meal at homes and restaurants, often as a porridge or pudding. It can also be combined with cooked rice cereal or prepared as cowpea cake. Cowpeas are consumed another way as a fast food called akara, sold along Nigeria's roadsides. It's also used as fodder in some parts of the country. The cowpea plant is attacked by pests during every stage of its life cycle. Aphids extract juice from its leaves and stems while the crop is still a seedling, and also spread the cowpea mosaic virus. Flower thrips feast on it during flowering. Pod borers attack its pods during pod growth, and broadleaf weasels attack the post-harvested seeds. The plants are also attacked by diseases caused by fungi, bacteria, and viruses. Parasitic weeds, striga, and electra choke the plant's growth at all stages, and nematodes prevent the roots from absorbing nutrients and water from the soil. Most cowpea crops are rain-fed, and although it is drought-tolerant, cowpea farmers in the dry savanna areas of sub-Saharan Africa obtain low yields estimated at about 350 kilograms per hectare. But Sulaiman and scores of farmers like him are being introduced to a new seed variety, a variety just developed by the Institute for Agricultural Research at the Ahmadu Bello University in Zaria.
But with the program in place now, we see some improvement because of new variety of seeds we get now. We are hopeful that those with the program will give priority to the new variety of seeds so that we can in turn make huge profits.
After going through the relevant trials, the federal government, through the nation's Biotechnology Regulatory Agency, the National Biosafety Management Agency, recently gave it approval for the environmental release of the nation's first genetically modified food crop, which is the pod borer resistant cowpea. This has been genetically modified to resist the insect pest Maruca vitrata.
The story behind these beans dates back to around 2001, about 19 years ago. Over the years, there is this particular insect that is so very difficult to control by farmers in the field. It inflicts damages to beans in the field where farmers lose up to 80% of their harvest at full infestation of this insect. Scientists like myself and insect scientists in the cowpea family have tried all things possible to control this insect, and all measures have failed except using heavy loads of chemical insecticides to control it. And we know that these chemicals are not only harmful to human health, but they are also toxic to our environment. So anything that we can do to avoid that very frequent release of this insecticide our environment is very good. Besides, also, if we can make it affordable and cheaper for our farmers to grow cowpea. One of the highest source of cost for growing beans for farmers will tell you, is the need to keep insecticides. Now, having tried everything and except insecticide, it became very difficult for us as a scientist until recently, when it was possible for us to develop a new scientific approach using genetic engineering technique, where you can transfer heritable characters and improve a crop outside a species. For example, I can use characters from rice to improve guinea corn, for example, if the characters are not found in guinea corn. So unfortunately for us, in the whole of the beans family, there are up to 15,000 different relations of beans, different types. And all of them were evaluated for resistance, so that if a single one of them found to be resistant, they can be used to develop new variety that is improved in giving high yield and also resistant to these insects, such that farmers will not need to spray as much insecticide on it when they are growing in the field. Unfortunately, none of these 15,000 different strains of beans turn out to be resistant. So the only thing available for us towards developing a new variety of beans that will protect itself against this insect without having to spray insecticide is through the use of the genetic engineering technique, which is called genetic modification. As soon as we got hold of this technique, myself and my colleagues went into work and were able to use this, and now have developed a cowpea variety that is resistant to this insect. Even without any spray, you can grow these beans and it will protect itself against this insect. However, it is not only one insect that affects beans in the field. There are many others. These other insects contribute up to about 20% of damage they give to beans when they are grown in the field. For this purpose, then there is a need for a supplementary spray, which is decided at a very specific time, identified by our scientific team. So these beans, which is developed using this new technique of genetic engineering, is able to give an opportunity for our farmers to grow beans cheaply because they now don't need to spray as frequently as they used to do with conventional non-resistant cowpeas.
This move by the government pitches Nigeria as the first West African country to genetically modify the food crop, which is currently going through the final process for its commercialization. The supporters of this process says the success of commercialization of BT cowpea will make Nigeria the leader in the deployment of the revolutionary technology in addressing the challenge affecting the nation's food chain, and will no doubt be used as a model for other West African nations in the deployment of the technology.
The result in terms of resistance to food borer was excellent, and also in terms of yield was also so far, because it was about 3 to 4 times yield increase over the conventional type. Also, it has a very good fodder and it's early maturing. So you can think of that it's a kind of variety that will be a modern day variety, because it will adapt the current climate change that we are also experiencing. So based on that, we now came up with a material that will say, oh, this one they are candidates for what? For release. It can be released as a variety for commercial use. Luckily this year, after a series of testing, the National Biosafety Management Agency, who are also the one that are supervising the safety aspect of the gene and also the whole work that was conducted for the first 10 years, they confirmed to us that Based on the result that we submitted, and also they also keep on monitoring, they confirm that the gene has no effect on both environment and also food and feed. So it's safe for that. So it can be used for both food, feed, and also environmental release. So they confirmed to us that. Then we are now trying to get more dossier that will also, as a conditions for us to get it in order to present it to the variety release committee in the country for release and for use by the farmers. So that's what we are, the state we are. So this is what we call the nucleus seed. As you are seeing here is the nucleus seed. After testing and find out that the resistance is there, now we are multiplying this seed at least to get more. So because based on the seed, it's one of the criteria that also needed to all conditions for us to release, because we have to get a certain quantity and also present the data to the variety release committee, which is normally a kind of meeting that is held once or twice in a year. Hopefully, we are expecting probably by the end of this 2019 call for a meeting. So that's what we are doing here to get the minimum requirement for the seed quantity, and also the other dossier is already been generated. We have those kind of data.
We keep them here under controlled temperature.
Hamza Adamu is the technologist in charge of the insectary at the Institute for Agricultural Research at the Ahmadu Bello University, Zaria.
I'm telling you, I'm the one who handled this transgenic right from the beginning of the project. I find it very, very interesting. More especially if I go to the field to put this insect on the plant. You put the insect on transgenic and the non-transgenic. If you come to evaluate or assess what has happened to the different lines, you will find out that these insects, you will see them dead on the transgenic cowpea without harming the cowpea. But in the other lines, which are non-transgenic, you will see them, they are just feeding the leaves, feeding the flower buds, feeding the flowers, just scattering everything. So I say, that means this technology is working, because you see this one very good, very clean, this one completely tattered, nothing on it. So I think it is nice, it is a nice technology. And if people can accept it, I'm telling you, we will have a cure to our problem of food insufficiency in the country.
But there are some that are preaching caution in the adoption of genetic modification in the food chain.
We're not against science. The reality of the life world we live in now is that we need a lot of scientific improvement to be able to grow enough food. For instance, take the fact that we're in the era of changing climate, where rainfall predictions are not regular, where flooding occurs where it's either so was not happening, or where the temperature, sometimes when you expect it to have calmed down, the temperature is still so high. So you need to develop your seeds, for instance, such that it can resist some of these extreme weather events. And also we know that you need to have seedlings, for instance, that grow better. Even sometimes you can have seedlings that have some components of what is deficient in the human system. There are improvements, no doubt. We know about biotechnology. Whether the science is right or not, that this has raised agitations in other parts of the world. That there are court cases in places in Europe, in India, that there are countries that are saying no to this same thing, and there are allegations of its effects, even as close as Côte d'Ivoire on their cotton industry. If this exists, then it means that you as a government owe it to Nigerians to allay any fears and to open it for robust discussion.
The report of the assessment of the risk of Bt cowpea to non-target organisms based on the history of safe use of Bt proteins, as well as the fauna associated with cultivated and wild cowpea in sub-Saharan Africa, results indicate negligible effect on non-target organisms. Genetically modified foods are developed and marketed because there is some perceived advantage either to the producer or consumer of these foods. This is meant to translate into a product with a lower price, greater benefit in terms of durability or nutritional value, or both. Initially, GM seed developers wanted their products to be accepted by producers and have concentrated on innovations that bring direct benefit to farmers and the food industry generally.
I can develop new varieties of beans using relations of beans. I can improve genetically sorghum or guinea corn using relatives of guinea corn. Now, this new technique entails crossing over from sorghum to beans, or from rice to beans, or vice versa. Then people said, since this thing does not occur frequently in nature, then we need to be careful to study whether or not it is going to have some problems. And it was understood. So there are measures to test the health status as food and feed, and also it is safety to the environment.
The GM crops currently on the market are mainly aimed at an increased level of crop protection through the introduction of resistance against plant diseases caused by insects or viruses, or through increased tolerance towards herbicides. Resistance against insects is achieved by incorporating into the food plant the gene for toxic production from the bacterium Bacillus thuringiensis, otherwise known as BT. This toxin is currently used as a conventional insecticide in agriculture and is said to be safe for human consumption. GM crops that inherently produce this toxin have been shown to require lower quantities of insecticides in specific situations.
For most crops, Nigeria is doing less than 30% yield per hectare. So the whole idea first is, how do we grow more food, enough food, without even increasing the hectare of land that we are using? So it is about the knowledge, and I'm not talking GM knowledge. Growing the same crops that our farmers, our women, hardworking women and men farmers are growing, is about how do we help them to grow smarter, requiring using water more smartly, like drip irrigation. Even where they are using fertilizer, how do you apply fertilizer with precision, not the way we spray, and it ends most of it go into the water body and pollute. How do we help them to survive the heat? Even simple knowledge like mulching and all of that, how do we help farmers so that their crops don't? How do we provide timely information, especially climate information?
While theoretical discussions have covered a broad range of aspects, the three main issues debated are the potentials to provoke allergic reaction, gene transfer, and outcrossing.
Some they say, no, these materials, if this materials is released because it's transgenic, there's every tendency for this material to be harmful to the non-target organisms. So we address all that concern through the kind of research that we conducted called non-target organisms. We did that one for several years in Zaria, and also Aminjibur and Bakura site. We found out that this gene has no effect with the non-target organisms. So it has no effect with the non-target organisms. And also there are other concerns. Maybe some they say, if you release these materials, it may also affect in terms of gene flow. So it may also come and there's a kind of unintended marriage. So the pollen will from the transgenic to non-transgenic or to even to wild type, it become a superweed. Then based on that, we also initiated a kind of study which is called a seed density trial. So with that one, we conducted it with a wild type, conventional cowpea, and then also the transgenic one. So we did it for about 4 years in Zaria, where we left it uninterrupted. What we realized that there was no evidence of a kind of gene flow that will make the transgenic or conventional to become a superweed. So we have also addressed that one. Then another one, they say, this your coffee variety, because it's transgenic, it may have a kind of an allergens. So that concern also, we try to address it, where we conducted a kind of compositional analysis, where we analyze both the grains, the fodder, the leaves, the fodder, which is the stems, and also the grains. We tested kind of approximate analysis based on the nutritional content. There's no different from the conventional one. So also in terms of phytate level, which is anti-nutritional factor, phytate acid, we also, if it is too much in the cowpea, it may have a problem in terms of digestion for both animals and also human beings. So we also conducted that test, both grain and fodder, the leaves and also the stems of the cowpea. We have done all that. The study was monitored by the NBMA, that's Nigeria National Biosafety Management Agency. Also, the result was submitted to them. It was reviewed, and they confirmed that the gene has no effect on both environment, non-target organisms, and also for human, both animal and human, as a food and feed for both human and animals.
For consumers to be able to exercise real choice, campaigners say it is obvious that the labeling program should fulfill this role. However, if ordinary and natural seeds are contaminated with GM seeds, people who wish to avoid eating GM foods will be deprived of choice. And they're asking the government to define who bears the responsibility should something go wrong.
Owned by Nigeria, is a Nigerian government-owned research. It does not belong to any multinational for that matter. And Nigerian seed laws are well explained. The federal government of Nigeria has structured the economic policy towards seed acquisition and who has it. And this particular beans is not having any exception that will make any multinational dominate over the seed supply and how it is going to be used.
We have representation and we have regular consultation. On this specific issue, there's never been any consultation. We have not had our parliamentarians go to their various constituencies to discuss these issues. We have not had the national orientation agencies informing us about this. Government don't sponsor ads in the media to say, we are having this challenge, this is the solution we are introducing, we have heard about this possible implication, but this is how we want to allay your fear. It's not there. Government has just decided, go and eat this. So 20 years down the line, if we now start to learn new things about this solution and some problems then emerge, how do we deal with it? Who is going to be paying compensations? What compensations will we pay for perhaps diseases that are not curable, or perhaps for lives that would have been lost, or some other implications that we might have? So if we took the decision together, then we know that way. But if some people took the decision on our behalf, then we will feel that people have betrayed us.
The anti-GMO campaigners say that the argument that GMO seeds are the only way to feed the growing world population is an emotional blackmail, saying in those countries where people are starving, lack of food is hardly the main cause of hunger. They say there exists a need to create a sustainable livelihood for everyone. From the Prince of Wales to notable scientists and politicians around the world, many are warning that companies developing genetically modified crops risk creating the biggest environmental disaster of all time. The release of GMOs into the environment and the marketing of GM foods have resulted in a public debate in many parts of the world. This debate is likely to continue, but the big question that every scientist, politician, businessman, and consumer must answer is, on the long run, are GMOs good for man and environment? That's our program for today. Thank you for watching. We'll see you next week.